Hi and welcome to E-ZTutoring. Today we're going to cover how to graph an ellipse given the equation. So the standard form of an equation of an ellipse goes x minus h squared over a squared plus y minus k squared over b squared equals 1. Now there are a number of things I would like to cover about this equation. I will cover them first, and then once I start graphing them, I will explain what they mean. So first things first, a squared will always be bigger than b squared. A squared is bigger than b squared. Now, why am I bringing this up? Well, since a squared is bigger than b squared, a squared will always come first, and you will always see it in the first fraction. Now in the first fraction, we have x squared on top. Sometimes you will have y squared on top. When you have y squared over a squared, your ellipse will be vertical. It will be like that. When you have x squared over a squared, your ellipse will be horizontal, and it will be like that. So that is one thing that's important to know. And some minor things will change when your ellipse is vertical rather than horizontal. For example, the coordinates of your foci and things like this. I will only cover the horizontal form. So if you guys would like to know the vertical form and some of these coordinates and formulas and stuff, you can do a little Google search. But at the end of the day, it will follow the same steps I'm doing, just with a little tweak to the coordinates. Anyways, enough of me chit-chatting away. Time to find our C value. You will need a C value to find your foci. And I will explain what foci are later. So your C value you can get from c squared equals a squared minus b squared. This is a little tweak of the Pythagorean theorem. And in order to find C, all you do is you square root each side. So after you've found C, then you can find your foci, which are located at h plus or minus c, comma, k. Now, this is for the horizontal form. For the vertical form, it will actually be h, comma, k plus or minus c. So little differences like that. All right, and then we can find our length of our major axis, which is going to be 2a. Now, our major axis is simply it's a length that goes from the head to the other head of the ellipse, and you have the major one is the big one, the minor one is the smaller one. Of course, given by their names, major and minor. Your minor is 2b. All right, so this is pretty much all you need to know about an ellipse. Once you know all this, you can go ahead and graph it. So let's say we have an equation here. Let's say our equation is x minus 1 squared over 20 plus y plus 2 squared over 4 equals 1. All right, so obviously we can see that our a squared is bigger than b squared. Good. And we can see that x squared is above a squared. So therefore, our ellipse will be horizontal. So we can go ahead and follow this form of everything we've been doing here. Our a squared is indeed bigger than b squared. Good. So now we can go ahead and find our c value. We know that c squared is equal to a squared minus b squared. A squared minus b squared. 20 minus 4. 20 minus 4, that gives us 16. And then c squared is equal to 16. So you just need a number times itself equal to 16. C is 4. Now, now that we found our value of 4, we can go ahead and plug that in to find our foci. So our foci are going to be located at h plus or minus c. So our h value is 1. And oh my god, I forgot to label the center. I knew I was forgetting something. The center of your ellipse is at h comma k. H comma k. So let's go ahead and actually find that first. Our center is at x minus h. So we need h. This is x minus 1. So our h is 1. It's pretty much the same thing as taking the opposite sign of this number you see here. So our k value is the opposite of plus 2, which is negative 2. And if you have trouble seeing that, it's really because this is the same thing as saying y minus negative 2. So that is how you can find your h and k. Okay, so now that I cleared that up, now we can do our foci, which is h plus or minus c. So our h value we know is 1. That comes from the center. 1 plus or minus c. 1 plus or minus 4. So let's do 1 plus 4 first, which gives us 5, comma k, negative 2. And then let's do 1 minus 4, which gives us negative 3, comma, k, negative 2. Those are your two foci points. After you found your foci points, we can find the lengths of the major axis and the minor axis. So to find this length, we will need to know a. Now, a is pretty much the square root of this. We're given a squared, we're given 20, so a is simply the square root of 20. And then we do 2 times the square root of 20. So the length of our major axis is 2 square root 20. The length of our minor axis is 2b. b squared is 4, so therefore b is 2. 2 times 2 is 4. All right, so we found everything we need in order to graph this ellipse. So let's go ahead and make some room here, and we can start graphing. So we will make our xy coordinate plane here, and now I will begin explaining what everything means. All right, so we can start off by labeling our center, 1, negative 2. This doesn't need much explanation. This is simply the center of our ellipse, 1, negative 2. After we've labeled our center, then we can label our foci at 5, negative 2, 2, 3, 4, 5, negative 2, right over there. I'll label this as F. And negative 3, negative 2, 1, 2, 3, negative 2, and I'll label this one as F as well. All right. Now our major axis is 2 square root 20. So the major axis, like I said, goes from head to head of the ellipse. Square root 20 is somewhere around 4.5, something like that. So if we multiply 4.5 by 2, that'll give us roughly 9, right? I would recommend doing this with a calculator to be more exact, but I will say it's 9, which means that if we look at our center, we know it's going to go 4.5 this way, and we know it's going to go 4.5 this way to make a total of 9. So if we go 4.5 this way, the end of our ellipse is going to be there and there. Now we can do the same thing with the minor axis. The minor axis is 4. And if we look at our center, then we know it's going to go 2 up and 2 down to make a total of 4. So we go 2 up and we go 1, 2 down. And that whole thing makes 4, and that whole thing makes 9. So now you can go ahead and connect the dots, and you get an ellipse that looks like this. Now, of course, your ellipse shouldn't be as lopsided as mine. I hope you're a better drawer than me. But one thing I did want to go over is, what do these foci even mean? What it means is that pretty much any point that you choose on this ellipse, let's say we choose a point right there. If we take the length from this foci to there, and the length from this foci to there, then this length plus this length, we'll call it length 1 and length 2. The sum of these lengths will be equal to the sum of the lengths from any point on this ellipse. So if you choose that point, or if you choose this point, or if you choose this point, the sum of these lengths will always, always, always be the same. All right, so that is how you graph an ellipse, and that is what all these different things mean about an ellipse. Like I said, it will be a little different for graphing a vertical ellipse, but for the most part, the steps will be the same. Hope you guys understood this. Hope everything makes more sense now. If you guys ever want ACT or SAT help, be sure to visit my website, www.e-ztutoring.com. Thank you guys, and have a good day.